Hi everyone, and welcome to the first video in a series of videos where I will be covering the five major big ideas as outlined in the AP Computer Science Principles course as proposed by the College Board. And this is all in preparation for the upcoming AP exam, which is coming up uh, within the first 2 weeks of May. So I'm going to be covering a lot of these big ideas based on the responses of the surveys that I have received from all of you. And today we will be covering the most requested big idea for me to cover, creative development. And to pretty much answer the one big question many people may end up having is what exactly is creative development? For me, I would probably end up defining it as a way of pretty much programming something in a way that's never been done before or in a really clever way. But for the purposes of the AP exam, College Board has defined this big idea to end up encompassing both collaboration, program function and purpose, program design and development, and identifying and correcting errors. And in our case, I'm only really going to focus more on the last three as opposed to all of them. And the big reason why is because as much as I would like to end up covering collaboration, it actually isn't tested by the College Board on their AP exam for the course. So I'm not really going to focus too much time on it because the last three are actually tested and, in my opinion, are absolutely more critical in comparison collaboration on program design. So first, let's pretty much end up covering uh, this first concept in regards to creative development. What exactly is you know the function of the program and its overall purpose. And what it pretty much encompasses is it allows us to be able to end up investigating the situation, context, or task. So suppose you're given a block of code, you need to be able to essentially understand how it works, in what context, and what exactly is the task it's being performed. What work is it doing that's going to be useful for us down the road? And this can also end up covering things such as the generalization of data sources through variables. Everyone should already be familiar with this concept. It pretty much ends up involving, all right, you have a program, it ends up accepting user input. How can we store this? Well, it can be stored with a variable, or you can just and making use of this source of data directly into a function without having to store it in a variable. And of course, this has a lot of pros and cons to it. A pro in just directly feeding the information into as an input for a function is you're not necessarily wasting any kind of memory. You're not spending time to end up creating a specific variable to hold that information. However, a con to that is since there's no memory allocated for this source of data through a variable, then you won't be able to make use of it again. And likewise, when it comes to making use of a variable, a con could obviously be that it takes up memory because a lot of programmers always aim to make use of as little memory as possible. Because remember, back in the day, during the Game Boy Color days, a lot of those Game Boy cartridges were only so big. If my memory is correct, they were at least about 128 kilobytes of memory, and the fact that an entire game was able to fit into yes that small little cartridge at exactly 128 kilobytes shows you how efficient and how creative a lot of these developers were for the Pokemon games, and that's in comparison. to a lot of like the modern day AAA games. For example, just the other day I ended up installing Shadow of Shadow of War, which is a game set within the Lord of the Rings universe, and it's like 100 gigs of memory, and that's pretty much absurd to how that kind of game can end up taking up that much memory. Because to me, it shows me that the developers haven't really been as creative. They don't care much about the memory footprint in general, in comparison to when back in the day, an entire game could be fit into 128 kilobytes, and it's still remembered as one of the best franchises to this day. And apologies for kind of like on that small little anecdote, but I do feel it was relevant to this presentation. And the final point I do want to end up making in regards to this critical idea of the program function and purpose is you must also be able to explain how a code segment or program functions. This has been tested on before in the past, and it will not go away. It is of critical importance for a programmer to be able to not only understand how a segment of code or a program functions and what useful computation it does for us, they must also be able to explain it in plain English if necessary to other people to end up explaining how the program works. You don't have to go into the nitty gritty details of it, but it is absolutely critical to be able to understand and explain the code to someone else. So, and we can kind of get started with this critical idea with a quick example. And I would like to state that this block of code, this diagram, was taken from the 2020 Practice AP exam, so a Practice AP exam from last year. And if anyone ever wants to try and like find it up for reference, and it is publicly available, go for it. And that's how I pretty much ended up finding it. But to pretty much, get back on track and focusing on this example. So suppose we have this, high level diagram of a program, and sometimes in this case, yes, even a high level diagram is more than sufficient for someone that is comfortable with programming to be able to decompose this and be able to explain it really well, and also pretty much look at the overall solution of it as well, pretty much showing what the end result will be and how it'll do. So there are pretty much two ways of understanding the overall behavior of a program. One way is pretty much, the long way is tracing the full program. No one is necessarily going to stop you from doing the long way, but I would also like to introduce that there is a short way of doing this, which is a much more efficient way of accomplishing this, especially if you are on a time crunch, and it helps develop a lot of your critical thinking skills when it comes to understanding segments of code. My expectation is that not everyone will be able to do the short method right off the bat because it's a work in progress. I do encourage everyone to pretty much go online, find Python code, look at it, and in fact, I will be covering a lot of different Python code in the future. I just have to pretty much still end up having time to prepare, record, and deliver. But just to continue, we're going to first get started with the method of tracing this program the long way, which is yes, tracing the program, and we can kind of like see how this is accomplished in the following way. So let's just kind of like put this up in a corner to make sure that my workspace is pretty much clear. So this is the program trace method, where we pretty much end up, starting with anything that's already given to us. The diagram shows us that the variable x is going to be initialized with the value of 2. So one way is me just putting down, start, meaning that x is equal to 2. So far, so good, right? And just like what I ended up mentioning, it corresponds to this section. Now, for the repeat 4 times, another way of thinking of the repeat 4 times is iterate. I, when it comes to programming, specifically Python programming, there are two methods of iterating through a sequence of items, and these items can either be within a list, within a dictionary, or just even a simple sequence of numbers from, in ascending order. It does not matter as long as it is something that Python can iterate through. So one way of pretty much tracing this is notice how I'm pretty much expanding this section of code into what I have shown here, because since we know that we start with a value of 2 for x, one can simply just understand that in the first loop, it's 2 is going to be multiplied by 3 and it's going to be equal to 6, and this value of 6 is being stored into variable x. On the second iteration, this value of 6 is multiplied by 3 again, and the end result will be 18, and this value of 18 is again stored back into variable x, so on and so forth, up until the fourth and final iteration, where from the third iteration we find that the end result will be 54. This value of 54 is being saved back into the variable x, and once saved, it pretty much on the final iteration, it gets multiplied by 3 again, and the end result will be 162. And that is our final answer. But notice how this is much, much longer in comparison to the short way, which I will be showing soon. But yes, keep in mind that this is a valid method of understanding a piece of program. However, I would like to add that yes, because this is a valid method, does not mean that it is a efficient method. So now we're going to be looking at the short way example, and this method is, in comparison to the long method, is a lot more efficient, and I will be highlighting the reasons why. And a critical thing that can be exploited for the short way is your knowledge and your understanding of not only programming but also math. So to begin, we pretty much end up starting in a similar fashion as we did in the long method, but this is where it starts to deviate. Yes, because we have the exact same um, beginning of this process does not necessarily mean that it will still end up being the same, because I'm just starting it out of habit, because we are working with a variable that is being initialized in the beginning. So a critical way of thinking it is repeat 4 times. Well, isn't that just the same as doing the same operation exactly 4 times? In other words, this being since x is being multiplied by 3 every single time, and this is being repeated by 4 times, we can just simply express this as 3 times 3 times 3 times 3 times whatever the initial value of 2 is, which is, whichever the initial value of x is, which in this case is 2, to end up giving us the exact same answer as in the long method, which is 162. And if anyone has any questions or concerns on this, please pause the video now, think about it for a little bit longer, and if you still don't quite understand, feel free to end up shooting an email for me to be able to answer this question, or just wait until the Discord session. And at this point, just pause the video, take a look at it, and think about it for a bit, and there will be 10 seconds of silence. All right, time to move on. So we've already covered, the second uh, of these critical ideas for the big idea, which is the program function purpose. Now we're going to move on to describing exactly what exactly does it mean to pretty much talk about program design and development. And in essence, a lot of the ideas in this critical idea pretty much are pretty similar to the critical idea of program function and purpose, but slightly different because now we are talking about program design and development. And in this case, it's all a matter of determining an appropriate method or approach to end up achieving the purpose. And and in a lot of different programs, there will be different methods of trying to end up achieving the same old purpose. If you want to loop through something, you can either go with a for loop or a while loop. And that is just one example on how there are multiple approaches of, yes, repeating the same block of code multiple times. There is a distinct difference that the for loop can be seen as something finite, whereas the while loop has more of a potential of going into an infinite loop. But it all depends on the kind of conditions that you are passing it to these kinds of looping statements. The another idea that falls under this critical idea of program design and development is having the capacity to be able to explain how collaboration affects the development of a solution. This won't necessarily be something that I will be covering because collaboration is something that's slightly out of the scope of my overall goals to be able to teach you guys. I'm not saying that it's something I am not going to be doing, but it's something that is outside of the scope of what my overall goals are. And finally, the final idea for this is in acknowledging the intellectual property of others. I know that at first read, or just even hearing this, it may sound confusing, but it all boils down to this: give credit to where credit is due. If you are working on a programming project that's collaborative in nature, then you must be able to acknowledge what others have contributed to this project while also ensuring that you yourself acknowledge what you have put into the project, and making sure that your fellow colleagues are also attributing and acknowledging the work that you put in. And now we're going to go down into the fourth and final critical idea for the creative development big idea, which is in identifying and correcting errors. And all that this really encompasses is being having the ability to identify and correct errors in algorithms and programs, including error discovery through testing. Something I could talk about is testing your programs, because there are various methods of testing your programs. There are things such as unit testing, where you are testing individual components of a program through some test cases to pretty much end up making sure that it is able to withstand the rigors of various different inputs, that it's not going to crash, that it's not going to enter into a kind of infinite loop, that it is able to withstand on its own. Another kind of testing is integration testing. And what integration testing encompasses is where unit testing involves the testing of individual units of a program. Integration testing involves integrating all of these units together to for each one of them to start working with each other, because some of these units may end up receiving as input information from another unit, and then providing output as input for another unit. So everything's interconnected, it's all integrated. You want to make sure that if your program is integrated through various functions, through various objects, through various classes, that it is able to make sure that when everything's working together, there are no crashes and there are no errors. And there is a third and final type of testing when it comes to making sure that your uh, program is, for the most part, error free. Uh, there is a third one, but I will not be discussing it simply because how it's slightly more out of the scope of programming, but it is still something important. I will be able to provide some links later uh, in the description down below. But one thing I would like to add, that even though I didn't have any examples for these two critical ideas, does not mean I am not going to go more that I'm not going to go more in depth in them. In fact, I've actually saved these two for last for me to be able to end up running uh, some basic Python code. So my whole objective is pretty much starting with a problem statement. All right, there's a problem statement. How can I apply programming to be able to find a solution to this problem? And that ends up being part of the program design and development. How do you tackle that kind of process? And as I'm writing out the code, it also comes without saying that it would also end up involving identifying and correcting errors, because during the development of a program, you are also asking yourself, hey, what else can I do? If I do this, is it going to break? Is it going to introduce a new error? If it does introduce a new error, how can I fix it? Will I be able to recognize what is going wrong? And a lot of these questions will be answered in a future video that will be coming out shortly, and it will be essentially a live coding session. So, with all of that, I do hope that you all have a good day, and please feel free to shoot out a email at the provided email address. Mr. Whaley will be providing this, or you can also uh, send a message in the Discord server with any questions that you may have. And with that, I'm signing off. Thank you.